Okay, good afternoon to everyone. So we will just have a substitution technique for definite integrals and some practice exercises. Okay, start with example 1 there. Now, there's one way to evaluate definite integrals, and that is by using directly x to evaluate it by plugging in the lower and upper limits. But since we will be using substitution anyway, so instead of reverting back to x and going back to the original limits, we will just remain in the variable u, but we will have to change the limits. So we will have new limits for our integration here, as I will illustrate. So looking at the example there, we want to find the definite integral from 3 to 11 of 1 over square root of 2x plus 3 with respect to x. Now, we cannot do this directly, so we have to use substitution. We let u be 2x plus 3. So if we do that, then we have du equals 2 dx. And instead of, as I have said, reverting to x, we will just change our limits. Now x goes from 3 to 11. So if we plug in those values, our u will go from 9, 2 times 3, 6 plus 3, 9 to 25. Now, you can obtain those limits by plugging in x here. You plug in 3, you get 9. You plug in 11, you get 25. So those will be our new limits. So changing the integral now, we have, if we denote this to be I, then the integral there is now equal to integral from 9 to 25, because we're converting now to u. So we use the limits for u instead of the limits for x. And that will become 1 over square root of u, and then dx becomes du over 2, or 1/2 du. You solve for dx here, you'll be putting 2 below, so you will have du over 2 here. Now everything is in terms of u, so we just proceed as usual. We move the constants, if there are any, across the integral sign. And then we can think of 1 over square root of u as u to the negative 1/2. This one here is u to the negative 1/2. Okay? So that if we integrate u to the negative 1/2, we add 1, that becomes 1/2, and then we divide by 1/2. So we will have 2 u to the 1/2, or square root of u, from 9 to 25. Okay, for the limits, okay, let me show it. in detail. So we have here for u, okay, u is 2x plus 3. Now x goes from 3 to 11. So if x equals 3, you plug in u is equal to 2 times 3 plus 3. That gives 9. And if x is 11, then our u will be, using this again, 2 times 11 plus 3, which is 25. Okay, now going back, so we have 9 and 25 for our new limits, and we integrated this already. So we got 2 square root of u. Now we plug in the limits. So we have the following. We have, okay, 1/2 and 2 cancels out. So it's just square root of u. Okay, so we have simply square root of 25 minus square root of 9. So we have 5 minus 3. So now, is there any question on this one? They want to take a screenshot of how we got the new limit. Okay, then let's proceed to the next. Okay, please kindly mute the.
Your question.
Okay. Yes.
How did you get the limits of how did you get the limits of u again?
Here, I explained it a while ago. So the limits of x are 3 and 11, right?
Yes, sir.
So u was, okay, chosen to be equal to 2x plus 3. So given an x, there's a specific u. So here. So if x is 3, you plug it in there. X is 11, you plug it in, you get 9 and 25.
Okay, thank you, sir.
Gab is trying to enter the Zoom call. It's the same. No password is needed. So he shouldn't have trouble entering the session. Is he ready? Okay, let's proceed to the next. So, okay, let's do it again. One more time. How do we change the limits? It depends on the u that we have assigned. Always, the original limits are the values of x. So if we choose a specific substitution, in this case, we will be using u equals x squared plus 1. So that du equals 2x dx. Now, the new limits will be as follows. So if x is 0, which is this one, the lower limit, then u, according to the formula here, if we plug in 0 for x there, is equal to 0 squared plus 1. So we get 1. If x is 1, same thing, u equals 1 squared plus 1. So it will be 2. So our new limits now will be 1 and 2. From 1 to 2 instead of from 0 to 1, since we're going to convert to u. And we'll never be reverting back to x. You can revert back to x, same, but you have to use the original limits. But in order to avoid that rather lengthy technique, we directly use u, but of course, we need a change of limits as well. So here, the integral I is now equal to new limits from 1 to 2 for x sine u. And then dx, using this one, will become du over 2x by solving for dx and that one, the one box. So that x cancels out, okay, leaving us with 4 integral 1 to 2 sine u with respect to u. And we know that the integral of sine x or sine u is negative cosine u. And then from 1 to 2. And we substitute the limits, upper limit first. So we have negative cosine of 2, and then minus negative cosine of 1. So the answer is cosine 1 minus cosine 2. Okay, I did not...
Sir, shouldn't the constant be 2 instead of 4?
yeah, sorry. Should be 2. I did not even write it here. Okay, there should be... Okay, 2 there. There should be 2 here. Okay, so negative 2. So 2 cosine 1 minus 2 cosine 2. Now you can leave your answer in this way, unless, of course, we have exact values. And that happens when we have special angles. But 1 and 2 radians are not special angles. So if you want, or if otherwise specified, then you use your calculator, you put it in radian mode, and evaluate to the required number of decimal places. Okay, so the only difference is that we don't revert back to x, rather we change the limits. So let's have another one. So the limits are 1 and e, integral from 1 to e of ln cubed x all over x with respect to x. So anyone would like to suggest a substitution for this one? By the way, ln cubed x, what does this mean? This is simply ln of x quantity cubed. Okay, what would be the proper substitution for this one? Okay, u equals ln x. And probably this will become a power integral because of the power of ln x, which is 3. So if we do that, we'll get the following: du, derivative of ln x is 1 over x, then times dx, and then we compute the new limits. So if x is 1, u is ln 1, and ln 1 is 0. If x is e, U is ln of e, and ln e is 1. The new limits will be, okay, 0 and 1. So this integral becomes from 0 to 1, and then ln x is u, and then it's cubed. So the numerator is u cubed. And then over x, and then dx is x du. This dx here is replaced by this dx here. If you solve for dx, you will be cross multiplying. So you'll be getting x du here. And the x will cancel out, leaving us with just the integral from 0 to 1 u cubed du. And then integrate sa power integral u to the 4 over 4 from 0 to 1, and evaluate upper limit first, then lower limit, subtract, so we get 1 over 4. Okay, just chat if you have a question. Now we'll have a seat work. Okay, evaluate this definite integral.
Sir, can you go back so we can screenshot? Thank you, sir.
Okay. The proper substitution is u equals 1 plus x cubed. That gives du equals 3x squared dx. And then limits will go from so 2 to 9. Then we convert the integral, becomes integral from 2 to 9 x squared over u, then dx becomes du over 3x squared. Again, from here, we replace this dx. And x squared cancels out. We move 1/3 across. We get this 1/3 integral from 2 to 9, 1 over u du, which is the reciprocal integral. So that becomes ln. So 1/3 ln absolute value of u. The all are positive, so you can just get rid of that. Anyway, we get 1/3 ln 9 minus 1/3 ln 2. That's our answer. Okay, I hope you got the same answer.
So we don't have to simplify that anymore.
Yes, no need to simplify that unless required by the directions.
Okay, sir.
So you gave a set of exercises just this morning. We will be doing those. The indefinite integrals. So the only difference is we'll be reverting back to x. Now, when we do indefinite, let me just look at that. Okay, here. So let's start with, okay, sine one plus ln x over x. I hope you tried this already. Anyone has the substitution? Sige, pag-isipan nyo. There's sine, there's ln, there's a reciprocal. So there are 3 possible substitutions, but only one will work. Any guess? Okay, correct? This is actually a sine integral, or it will be converted to a sine integral, although it contains ln. But actually, the reciprocal there is the derivative of ln x. You have noticed that du is just that 1 over x dx. This one here. So that 1 over x will cancel out later when we convert. And then no need, okay, no limits. So we just have to convert, then revert. The integral becomes integral of sine u. So you have assigned u to the expression inside sine. And then over x, copy x, and then replace dx using this. Solving for dx, we have x du. And x cancels out, leaving us with just the simple basic sine integral, though in terms of the variable u now. And the integral of sine u is negative cosine u. Don't forget to put in the constant of integration immediately after you remove the integral. The next line should contain constant of integration.
Sir, to
And
clarify,
reversion,
we only use constant when there's no limits given.
yes, because you'll be evaluating. When you evaluate an integral, then you already add the constant of integration. If you remove it here, let's say you put it only in the last, technically that will be a wrong solution, although you have it in the final correctly. So put it right away after removing the integral sign. And that's when you're already evaluating it or finding an antiderivative. So plus c, and then revert. Final answer here. Any questions? Anything you did not understand? Anyone got confused? Okay, so the only thing here is to be able to see the correct substitution. Let's try the next one. Cosine square root of x over square root of x. And some of you might already be able to see quickly the correct substitution. Okay, any suggestion? Nothing yet? Anyone? Substitution is u equals square root of x, correct? What's du? You should be familiar, or you should have memorized by now the derivative of square root of x. It's 1 over 2 square root of x. Get that using x to the 1/2. You bring down the exponent, subtract 1. Then rewrite as a radical. And then, of course, since you have a negative exponent, you have to bring it down. Okay, let's convert. Integral of cosine u all over square root of x, and then dx is 2 square root of x du. Again from here. Okay, and it becomes just what? A cosine integral with a constant outside, 2. Integral cosine u du. So 2 sine u plus c, 2 sine square root of x plus c. Questions? Okay, next. Integral e to the x sine 3 minus e to the x. Okay, substitution. Be waiting for someone to suggest. Okay, be obvious. Notice the e to the x outside is the derivative of the quantity inside. So it should cancel out. What's du? You differentiate 3 becomes 0. And then the derivative of e to the x is itself. And then a negative sign outside. So that should be the correct differential. Du equals e to the negative x dx. Okay, then we convert so it becomes a sine integral. Integral of sine is negative cosine. Okay, next. Okay. Think of the correct substitution for this one. That's sine x. Okay, somebody suggested u equals sine x. Let's see. Okay, this is what happens when we try to convert this integral. However, though we have eliminated cosine x, the presence of cosine x there, the integral in the last line is for now beyond our knowledge or capability. We will go in the next module to integration by parts, where we shall see how we can find or derive the antiderivative of ln x. Okay? So suffice it to say for now that this problem is beyond our scope for the module, the present module. Okay? So we just say it's non-integrable for now. Does anybody have a question? Okay, this one is integrable.
Sir, will a question like that be on the quiz?
Of course, no.
Okay,
Just
sir.
to illustrate that some problems are not solvable unless you have the proper tools.
Sir, just curious, will we be learning the proper tools this course?
In the next module,
Ah,
integration by parts.
I see. Okay, thank you, sir.
Then after this, prepare your calculators. You'll be needing them for computing areas. Okay, I'll give you 5 minutes max to solve this one. Okay, so that's a correct answer. Let U be cosine X. We'll have the following. Okay, sorry, this should be negative sine X. Okay, so you'll have a negative outside. So final answer, negative e to the cosine x plus c. Okay, did you get the same answer? Okay, I gave you an assignment. Let's do it now. You were asked to find the area of the sine graph from 0 to pi. The graph is something like this. Don't really need to study particularly the graphs of trigonometric functions. So will just be given you if you're not familiar with the graphs. So from 0 to pi. We'll do it first by approximation, and then we'll use the definite integral to calculate the exact area. Now you were required to use 4 rectangles. So prepare your calculators and put them in radian mode. So we'll be dividing that, okay, into 4, 0 to pi. So what will the length of each subinterval be? Should be pi over 4. Pi minus 0, that's the length of the entire interval from 0 to pi. It's of length pi. Then we divide it into 4. So we have pi over 4. So next we evaluate or approximate using left rectangles. So we'll be using the left endpoints. And the rest would be to substitute into, oops, function here. That's where we will be putting them all. Now the length is pi over 4, the base of each rectangle, pi over 4, and then times the height, and then we will sum them up, so we can just combine them, factor out pi over 4. So beginning with 0, 0 here, up to 3 pi over 4, we'll just have the expression sine 0, sine pi over 4, sine pi over 2, sine 3 pi over 4. Okay, and the rest is calculator work. I want you to complete this one, do the right rectangles, and then get the average to obtain an approximation for the area. Okay, please use 4 decimal places.
Sir, 4 or 5 decimal points? 4.
Okay, surprisingly, should get the same value for left and right rectangles. You can see that once you draw the rectangles themselves. And also due to the nature of the graph of the sine function, which is cyclic. If you get the average, it will be the okay. So that's the approximation. Your sign would be to use 8 rectangles just for your practice and to obtain a better approximation. So let's compute now the area. So that will be as a definite integral. Lower limit is 0. Upper limit is pi. The function is x. So and we already have the formula. There's no problem with evaluating this one. So we have negative cos x 0 to. And if we plug in, okay, negative cosine pi minus negative cosine 0. So it will be cosine 0 minus cosine. That, okay, the exact area is 2 square units. And our approximation is 0.961. Not bad, but not too good as well. So you'll obtain a better approximation if you use more rectangles, increase the number. So 20 would be too many, so I'll just leave you with 8 rectangles to work with. And then that's it for today. I'll be just sending more exercises and sample quiz maybe tomorrow. Okay, so that's it. I'll be ending the session.